Okay, I'm back. All right, so we're going to continue on with talking about what we do now that, man, let me get back to where we were. Now that we know it's a type A, B, or C soil. So you remember the different tests that we did. And now we know that the greatest hazard of our excavations is a cave-in, okay? It's a cave-in, somebody being buried. That is the greatest hazard that we have to deal with. And so we've determined the different types of soils, and we need to be able to deal with those. Now, taking a look at this soil right here, and this is an example of a situation where 2 workers died. Okay, this material right here, what does it look like to you? To me, it looks very sandy. And so we would probably consider this a type C soil. So this crew was installing conduit. It was an 8-foot deep trench. We know now that we have to protect that because it's over 5 feet. It was 2 foot wide. The trench collapsed and 2 workers were buried. They're actually in this picture right here. 2 workers are buried underneath that sand right there. That's pretty scary. And this happens over and over and over again. It is not something that has stopped happening because people know it's dangerous. People still get down in those trenches, and a lot of them just don't know any better. But this is definitely a type C soil. Okay, so I've already talked about this. We need to protect trenches over 5 foot in depth. That is our magic number. We've got different types of protective systems. Three different types. Now, within these types, there's a lot of different manufacturers and different ways to do this, but there's 3 main types of protective systems: support and shoring systems, sloping and benching, and shielding or trench boxes, shielding systems or trench boxes. And so I'm gonna talk about each one of those real quick so that you have an idea of how you can protect a trench, because there's different ways that you can protect a trench. Okay, so the support and shoring systems. Now, the way that these work is by pushing against the soil. Now, the theory of shoring, it prevents the cave-in. It's designed to push against the soil on either side and prevents the cave-in. Okay, and that's how it protects, is by preventing the cave-in. Now, a lot of these are hydraulic, so you'll put them down into the trench. Let me go back here. You can see that this one right here, these are hydraulic, and what happens is they put them down into the trench, they pump them up, and it pushes against the soil. There's also wooden shoring, and you can build wooden shoring just like this picture on the right. And your book, the 1926 manual, has the specifications for how to do that and what it can support. Okay, so that's shoring. Shoring pushes against the soil. Here's some improper shoring. So you can see that they have something that's pushing against the soil, but it's not built the way it's supposed to be built. When you have a shoring that's built per the OSHA manual, per the book, not the manual, there's certain surcharges that are allowed on that trench. And so 20,000 pounds of equipment if OSHA's timber or hydraulic shoring charts are used, and that's at a 1-to-1 angle. So any type of equipment has to be less than 20,000 pounds if it's built per OSHA's timber and hydraulic shoring charts. Now, the stockpile height can't be greater than 2 feet. Okay, so the stockpile on the side can only be 2 feet high, and it needs to be moved back 2 feet from the edge. The next is sloping and benching. And this is where it's really important that you know which type of soil it is, because you have to slope and bench per the different types of soil. So if it's a type A, remember a type A is cohesive and has a strength of greater than 1.5 tons per square foot. So that can be the steepest because it's going to hold together the best. And so that's 3/4 to 1. 3/4 to 1. The type B soil, which is between 0.5 and 1.5 TSF, but it's still cohesive, that can be 1 to 1. And then the type C, which is a sandy material, has to be 1.5 to 1. So for every foot that you go up, you have to go back 1.5 feet. So looking at this picture on the right again, remember I told you we were going to look at that again. This looks like a type C soil, doesn't it? So this being a type C soil, they need to be sloped back at 1.5 to 1. And to me, it looks 1 to 1 at best. So I don't think this is an acceptable situation on the right here, because we should be going back at 1.5 to 1. Now, sloping in theory prevents the cave-ins because it's sloped enough. And it's not going to cave in any more than it's already sloped back. There's different ways we can do this. So for a type B soil, for example, as long as we stick to that 45-degree angle, 1 to 1, whether we bench it or slope it, that's acceptable. Type C soil, you cannot bench a type C soil. And that 1.5 to 1, you can only do a 20-foot max. If your trench is greater than 20 feet deep, you need to figure something else out. You need to get an engineer involved in that. But you cannot bench a type C soil. So in this situation, we've got a slope to a bench and a slope to a bench, but we cannot have a vertical face because that vertical face is going to fail. So even if somebody is right here, they could be in danger, or somebody is right here, they could be in danger. So we can go slope to bench with type C. Now, the third type of system is our shield systems. Now, if you look at this picture right here, this shield is not touching the soil on either side. It is kind of down here and a little bit down here. But this is a shield system. This is doing exactly what it says. It's shielding somebody from a cave-in. It's not preventing the cave-in, it's just shielding them. And so we call these trench boxes. You don't usually hear them called shields. You'll hear them called trench boxes. And they're designed just to protect the worker that's inside. To be protected, the worker actually has to be inside it though. Because if they walk outside of the trench box, they are no longer protected. So if you take a look at this picture right here, this person right down here, you can barely see the tops of their head. They are protected. So there was a cave-in, and they're down in the trench, but they were protected from that cave-in by the shield. Now, at this point, you'd want to get that worker out. Now, the one problem I see with this, and maybe you've noticed too, is that ladder. That ladder is not in the trench box. So the worker has to leave the protection of the trench box to get on the ladder to get out. That ladder should be in the trench box where it can get out. You can see that this trench box is barely holding back the cave-in. Obviously very strained and very stressed. You would not want to get into that, but you can see that the soil has failed because of the moisture, and that trench box is doing its job. Here, we do not allow a person to walk between two trench boxes if there is a separation between them. So this one has a 2 or 3 feet separation. It's hard to tell from the picture, but If a worker needed to go from one trench box to the next, they would be at exposure at that point. So this is not an acceptable situation if people are moving from one side of the trench box to the other. Now, if they're working in one trench box and then they get out of the trench and go over to the other trench box and back into the trench, that's acceptable. This guy here, basically the only thing that's protected in this picture is the thing that's designed to be buried, the pipe. Why they're doing this, I don't know. This guy, he's going to hold back that soil, obviously. But they even have their ladder outside of this trench box. So both of these guys are at exposure. And then this guy up here sitting on top, obviously doesn't give a rip. He's up there just hanging out. Not a competent person. So if the trench is deeper than the box, there's things that you can do. You can slope down to the box at whatever that slope is for a type A, B, or C soil, and have an 18-inch lip at the top of the box, where if something did fail, it would be able to hit the edge of the box and not fall into the trench box. Once again, spoil pile still needs to be 2 foot back from the edge. And so this is what an option if your box is not tall enough. You're allowed to have the trench box off the bottom of the trench if you need it. So it can be 2 foot off the bottom. And this allows you to do work on pipe, or if you have pipes crossing through, it gives you room to have those pipes crossing through. This is acceptable because you're obviously not going to get buried by 2 feet of exposure down at the bottom. Okay, other hazards. People jump across trenches all the time, and that is not acceptable. So falls is a big problem. I almost fell into a 30-foot excavation one time, just being stupid. And that happens. People fall into excavations. They don't always get buried, but sometimes they get hurt falling into excavations. You can build bridges to get across. Putting a plank across and doing a little balancing act, like a slack line across of a trench, is not an acceptable way to get across it. Okay, and then we've got structures that could be close. Now, for those of you who are not engineers, you need to understand that there is a force put onto the ground by a structure. That's why we build footings. But from the bottom of the footing out 45 degrees, that structure is putting force onto the soil. So if you cut into that area of influence with your trench, you've got excess forces on your trench that can cause it to collapse. Okay, underground utilities. In Arizona, the way we do this is we call blue stake. And what blue stake is you call up a number, you say, hey, I'm digging a trench right here. And here's the location. I've marked out where I'm doing the excavation in white. And the blue stake will see which utilities are in that area, call all of those utility companies, and those utility companies have 48 hours to come out and mark any utilities that they have in that area. So you'll have a blue line on the ground. That's water. You have a red line on the ground. That's electrical. You have a orange line on the ground. That's communications or fiber optic. If you have a purple line on the ground, that's reclaimed water. If you have a green line on the ground, that's sewer. So all of these things get marked out on the ground, and it's the person who's doing the excavation's responsibility to make sure that they don't hit those. So if there is say a yellow line on the ground, that's a gas line. Very important that you don't hit a stinking gas line. All right, those go big boom. And so we've got a gas line going across. Before we do our excavation, we're going to do a pothole and try to find where that gas line is. So They mark it in one location. It can be 2 feet on either side of it. They have 2 feet of fluff, basically, of where you might find that gas line. And so you dig down and you search around by hand, not with a piece of equipment, and you find that gas line before you start digging, so that you don't end up hitting that gas line with a backhoe or piece of equipment. Same with all the other lines that are around there. But a lot of people get injured and hurt because of hitting things. I'm going to show you some videos, or I'm going to have some videos in that shell that you can watch, where people have actually hit lines, water lines, gas lines, all of the above. So this is a way that you can protect lines once you're in the excavation, is actually by stringing a big pole across and tying those things up. That's an acceptable way to protect those lines once you've found them and they're in your excavation and they're just hanging in your excavation. This is a video of a water line that was hit. This is a water line that was hit, and this is a huge gas line that was hit. So I want you to watch those, okay, so that you can see the power of these things. I've mentioned the spoils pile. The spoil pile needs to be 2 foot back from the edge because you have overhead hazards. Equipment being next to the trench. You need to protect things from falling into the trench, and also that surcharge that is being put on the trench by any equipment being near it. So vehicular and traffic hazards. Trenches are dug in roads all the time. We've got to make sure that the vehicles cannot go over into that trench. So it's got to be protected somehow. These are all other hazards that you have to deal with. In this picture, you can see that there's a lot of loads that could fall into this trench. So we've got a board, 2 by 12 or something over there, and then we've got a sheet of plywood and a CMU block that could fall into this trench. So you wouldn't want to be down in this trench because all of that could fall on your head. Not to mention, this is an unprotected trench, and that looks like type C soil. So we can also create a hazardous atmosphere down in the trench. So we see that there's a gas can and a running, looks like a sump pump of some sort, like they're pumping water out of there, which makes sense, but they shouldn't be down there with it because that's creating carbon monoxide, and it could settle in that trench and actually suffocate them. So it could be a confined space that we have to deal with down there. Water, when water is present, we have big problems in trenches. So remember, when water is present, what type of trench or what type of soil do we determine it to be? C, automatically. No matter what the soil type is, if there's water present, it's type C, and we should not get down in that trench. Access and egress. So we have to make sure that there's access and egress by ladder or by ramp or however we're doing it. We have to make sure that it's there within 25 feet of everybody that's working in that trench. So if you have an exactly 49 or 50-foot trench and you have a ladder right in the middle, that's acceptable because it's no farther than 25 feet from anybody in the trench. Once you go over 50 feet, you're going to need 2 ladders in that trench. So within 25 feet of everybody that's working in it. It needs to also extend 3 feet above the top of the trench. Now, this is a standard ladder wherever you're using a ladder, because somebody needs to be able to grasp that ladder and exit and step over the edge of the trench. So it needs to go up 3 feet. There are overhead hazards usually around trenches and excavations. So you need to be concerned with that, because OSHA requires that anytime there's an overhead hazard, you have head protection. So wearing hard hats. So that's where I want to stop. And I want to explain to you what your assignment is. So I'm going to go back to where I had that. and it's the competent person interview statement assignment. Now, what I'm going to have you do is I've given you a competent person interview statement. This was actually something that was given to me by OSHA, and these are the questions that would be asked of you. So I'm going to switch over to that in a minute, but I want you to take note of the scenario. So this is the scenario. You're digging a 75-foot long trench. It's 8 feet deep. You're putting in a 6-inch water line. The soil is cohesive. Okay, so you've determined by your manual tests that the soil is cohesive. You've also determined that it has an unconfined compressive strength of 1.0 tons per square foot using the thumb penetrometer test. Okay, so that tells you what type of soil it is. You should know that from it. Okay, now let me switch over to the assignment. So here's the assignment in BB Learn right here. So all of that information is there, but this is the attachment. So this is the competent person interview statement. I'm sorry, I don't have it in an electronic format because this is what was given to me by OSHA. These are the exact questions that an OSHA inspector would ask you. And if you don't know the answers to them, you are not competent, okay? So they're trying to determine if you're a competent person. So what I want you to do for your assignment is I want you to fill this out. Some of this information you're going to need to make up. So I've given you the important information, like all the information that you would need for the excavation itself. You can see what are the dimensions of the excavation. I've given you that information. Have you performed any manual soil tests? I've given you that information. What were the results? I've given you that information. You should know what type of soil and what type of protective system. There are certain things on here that there are right and wrong answers to. Okay, like, do you conduct inspections of the excavation? Yes, is the right answer. Okay, let me tell you this, because I think I may have skipped over it a little bit, or maybe said it really fast. You need to conduct, a competent person needs to conduct an inspection of an excavation or trench every day before they begin work or when conditions change. Okay, so every time or before every shift or when conditions change on the job. Okay, so do you conduct inspections of the excavation? If you're the competent person, you better, right? How often? You should know the answer to that question. When was the last one performed? If you say 2 days ago, that's the wrong answer. So make sure you know the right answers here. But I want you to go through this and I want you to fill it out. Like I said, some of this stuff you can just make up the answer to, like address, occupation, you know, that kind of stuff, inspection number. But I want you to fill it all out. And some of this stuff there are right answers to. Are you using any type of employee protective system? If so, what type? You can make up what type. I gave you 3 types that you could be using. Are you using any type of employee protective system? Yes or no? Well, you know how deep that trench is. I told you how deep that trench is, so you should know what the right answer to that is. Fill this out. You can print it and fill it out, or if you have some type of PDF writer, you can use that and just write on top of it with text boxes. But if you print it out, you can fill it out and then scan it with your cam scanner or however you want to take a picture of it and scan it into PDF and turn it in. So this is going to be your assignment that's due next week. I want to make sure that you get this in by Tuesday night. So once again, for this class, things are going to be due at 11:59 Tuesday night. Make sure you get this filled out. If you have any problems, give me a call, talk to me, let me know what's going on. So hopefully everybody understands this, but if you don't, send me an email, give me a call, whatever you need. And hopefully you guys have gotten something out of this. I'm going to go back to the Stop sharing my screen. So hopefully you have some basic understanding of trench excavation safety. Ultimately, I just want you to be able to be on a job site, know the hazards, know how you can mitigate those hazards, and know the basics and where to get to those basics. Now, I'm also going to put a link in the folder for an OSHA site that I want you to go to and I want you to check out, because this has a lot of the basic information in it too about access and egress and protective systems and pretty much everything you need to know about trenches in this one little easy to find format. Also, it has all the links to the regulations that go along with all of that. So I want you to check that out. But hopefully you guys are doing great, staying healthy, safe, and I will talk to you next week.